Hello. Thanks for joining us today. We are looking for a mid-level Flutter developer to join our team, and based on your background, you seem like a great fit. To get us started, why don't you tell me a bit about your experience with Flutter over the last 3 years?
Thanks for having me. Yeah, I've been working with Flutter for about 3 years now. I started out building smaller utility apps, but over the last couple of years, I've moved into more complex production-grade applications. I've taken ownership of several core features, from designing the data layer and API integrations to polishing the UI. I've spent a lot of time focusing on state management and app performance, and I really enjoy the process of breaking down a design mockup into a scalable widget tree.
That sounds great. Let's dive right in with some of the fundamentals. When you're building a UI and you have a widget, like a container or a text widget, that needs to respond to a tap or a click, how do you handle that?
Since those basic widgets don't have built-in click listeners, the standard way to do it is by wrapping the widget in a gesture detection widget. Depending on the desired effect, I'll use either Gesture Detector or Inkwell. Gesture Detector is the more general-purpose tool. It can detect a huge variety of touch events, not just taps, but also long presses, drags, and scales. Now, if I want the app to feel more like a native material design experience, I'll use Inkwell. The main advantage of Inkwell is that it provides that visual ripple effect when the user taps, which gives the user immediate feedback that the action was registered. In either case, I just provide a callback function to the onTap property, and that's where I put the logic for what should happen next.
Good. Now thinking about the project structure, could you explain the significance of the pubspec, YAML file? What exactly is happening in there?
The pubspec, YAML file is basically the configuration hub for the entire project. Its primary role is dependency management. Whenever I need an external library, like for networking or local storage, I list it there so the Dart package manager knows what to fetch. But it's more than just packages. It's also where I handle project metadata, like the app's version, name, and description. One of the most critical parts for me is the assets section. If I have images, custom fonts, or JSON files that need to be bundled with the app, I have to declare them in the pubspec, YAML. If a resource isn't listed there, the app simply won't be able to find it at runtime, and you'll end up with a missing asset error.
Right. Let's talk about memory and resources. Imagine you have a resource, maybe a database connection or a shared API client, that needs to be initialized only once and then shared across the entire application lifecycle. What mechanism would you use for that?
In that scenario, the best approach is to use a singleton pattern combined with a dependency injection framework, such as getIt or provider. A singleton ensures that only one instance of the class is ever created. This is crucial for things like database connections, because initializing a database multiple times is expensive and can lead to locked files or memory leaks. By pairing the singleton with dependency injection, I can decouple the creation of that resource from the UI. Instead of every screen trying to instantiate the database, they just ask the DI container for the existing instance. This makes the code much easier to test, because I can easily swap the real singleton for a mock version during unit testing.
That's a solid architectural choice. Speaking of the UI, I want to talk about scrolling. A lot of developers get confused between list view and single-child scroll view. When would you choose one over the other?
They both make content scrollable, but they handle memory and layout in completely different ways. I use list view when I have a list of similar items, especially if the list is long or dynamic. Specifically, I'll use the builder constructor. The reason is efficiency. The builder only renders the items that are actually visible on the screen. As the user scrolls, it destroys off-screen elements and builds new ones on the fly. This saves a massive amount of memory. On the other hand, single-child scroll view is more of a wrapper for a single child. It renders the entire child widget tree all at once, regardless of whether the items are on screen. So, if I'm building a settings page or a long form with a few different sections, I'll use single child scroll view. But for a list of 100 products, a list view is the only way to go to avoid performance hits.
Let's move into performance. You mentioned rendering performance. Could you explain the concept of recomposition and how Flutter manages it?
Rendering performance in Flutter is all about how the framework updates the screen. To understand recomposition, you have to look at the three-tree architecture: the widget tree, the element tree, and the render object tree. In Flutter, widgets are immutable. When a state change happens, Flutter doesn't just modify the existing widget. It triggers a rebuild, which is essentially recomposition. It creates a new version of the widget. The goal for any developer is to minimize how many widgets are rebuilt. If a parent widget rebuilds by default, all its children rebuild too. If you have a huge UI tree and you're rebuilding the whole thing for a tiny change in one text field, you're wasting CPU and GPU cycles. This is what leads to dropped frames or that laggy feeling in animations.
And how do you actually optimize that? How do you stop the whole tree from rebuilding?
The key is to localize state changes. I try to push the state as far down the tree as possible. For example, instead of putting a state variable in the main page, I'll create a small, dedicated stateful widget for just the part of the UI that needs to change. That way, only that small portion of the tree is marked as dirty and updated. I also make heavy use of const constructors. When I mark a widget as const, I'm telling Flutter that this widget is immutable and will never change. Flutter then caches that instance and reuses it during rebuilds instead of recreating it. This significantly reduces the workload on the framework, especially in complex layouts.
You mentioned const constructors. Just to be clear, why does that actually help performance under the hood?
Because when Flutter sees a const constructor, it stores that widget in a special place in memory. During the recomposition process, when Flutter compares the old widget tree with the new one, it sees that the const widget is exactly the same instance as before. It doesn't even need to check its properties. It just skips the rebuild for that entire branch of the tree. It's essentially a shortcut that tells the framework, nothing here has changed, so don't spend any time processing this.
That's a good explanation. Let's talk about the build context. I see it in almost every widget. What does it actually represent in the Flutter ecosystem?
Think of build context as a handle or a pointer. It tells Flutter exactly where a specific widget is located within the overall widget tree. Since Flutter is a hierarchy, a widget needs to know its position relative to its parents and children. The build context is what allows a widget to look up the tree to find data. For instance, when I call theme of context or media query of context, I'm using the context to search up the tree until I find the nearest theme or media query widget. Without the context, a widget would be isolated and have no way of knowing the global settings or the navigation state of the application.
Now let's move towards state management. For a 3-year experience level, you've likely used various approaches. Let's start simple. How does setState compare to something like Provider or BLoC?
setState is the built-in way to handle local state. It's great for something very simple, like toggling a switch or updating a local counter. It tells Flutter that the internal state of that specific widget has changed, and it triggers a rebuild. But as soon as the app grows, setState becomes a liability. You end up with prop drilling, where you're passing data through 5 different layers of widgets just to get a piece of information from the top to the bottom. This makes the code a nightmare to maintain. External solutions like Provider or BLoC decouple the state from the UI. They allow the data to live in a central store. This means a widget can just listen to the specific piece of data it needs. When that data changes, only the listening widgets rebuild, not the entire parent chain. It separates the business logic from the visual layout, which is essential for any professional-grade app.
If you were using Provider specifically, how would you actually access a change notifier from a widget?
First, I'd make sure the parent widget, usually higher up in the tree, is wrapped in a change notifier provider. Once that's set up, I have a few ways to access it. The most common way in modern Flutter is using Context Watch. That tells the widget to listen for any changes in the provider and rebuild whenever they happen. If I'm using a consumer widget, it's similar. It wraps a specific part of the UI and only rebuilds that part when the state changes. However, there's a big difference when I just need to call a method, like triggering an API call without rebuilding the UI. In that case, I'd use context read. Using read ensures that I can access the provider's functions without creating a permanent subscription that would cause the widget to rebuild unnecessarily.
Speaking of data, let's talk about fetching it. How do you handle asynchronous data fetching from an API within a widget?
For most cases, I use a future builder. Since network requests are asynchronous and can't block the UI thread, I wrap the API call in an async function using the await keyword. The future builder is perfect here because it's designed to track the state of that future. It gives me a snapshot that tells me if the data is still loading, if it arrived successfully, or if an error occurred. This allows me to show a loading spinner while the request is pending, and then switch to the actual data once it arrives. It keeps the app responsive and prevents the UI from freezing while waiting for the server.
And what if the data isn't a one-time fetch? What if you're building a chat app or a real-time ticker? Would you still use a future builder?
No, for that I'd switch to a stream builder. The fundamental difference is that a future builder is for a single event. You ask for data, you get it once, and you're done. A stream builder is for a continuous flow of data. It listens to a stream and rebuilds the UI every single time a new piece of data is emitted. So in a chat app, as new messages arrive via a WebSocket, the stream builder will automatically detect those new emissions and update the message list in real time without the user having to refresh the page.
That's a clear distinction. Now let's get into the more technical side of Dart. What are isolates and when should you use them instead of just using a future?
This is a really important distinction. A lot of people think futures are for multitasking, but Dart is actually single-threaded. A future handles asynchronous work, which is usually work where the CPU is just waiting, like waiting for a network response or reading a file from disk. The main event loop can do other things while it waits. However, if you have a task that is CPU-intensive, like parsing a massive JSON file with thousands of lines or doing complex image processing, that will actually block the event loop. This causes the UI to freeze, and you'll see the frames drop. That's when you use isolates. An isolate is essentially a separate worker with its own memory heap and its own event loop. Since they don't share memory, you avoid race conditions. You spawn an isolate to do the heavy lifting on a different processor core, and then send the result back to the main isolate when it's finished.
That's a very professional take. Let's shift to platform-specific logic. Since Flutter is cross-platform, how do you handle features that are only available on iOS or only on Android?
It depends on the complexity. If it's just a simple UI change, like adding a little more padding for the iOS notch or changing a button style, I'll just use a simple platform check with platform is iOS or platform is Android. But if I need to access something deep in the OS, like a specific sensor or a native API that doesn't have a Flutter plugin, I use method channels. This is basically a bridge. I write the Dart code to send a message across the channel, and then I write the corresponding native code in Swift for iOS or Kotlin for Android to handle that request and send the result back. For larger projects, I prefer a more scalable approach. I create an abstract interface in Dart and then create two separate implementations, one for Android and one for iOS. I then use a factory pattern to instantiate the correct one based on the platform. This keeps the native logic separated and makes the code much cleaner.
I like the factory pattern approach. Now let's talk about something a bit more advanced. I've heard about shader compilation jank, also known as first frame jank. Have you encountered this, and how do you diagnose and fix it?
Yes, it's a common issue, especially with complex animations, rounded corners, or gradients. It happens because the graphics driver has to compile the shaders for these effects the very first time they appear on screen, which causes a brief stutter. To diagnose it, I use the performance overlay and the dev tool's CPU profiler. If I see a frame that takes longer than 16 milliseconds, but only on the first run and not the second, that's a telltale sign of shader jank. The modern solution is to use the Impeller rendering engine, which is now default for iOS and coming to Android. Impeller precompiles the shaders, effectively eliminating this problem. For older versions, I'd use the SKSL warm-up process. I run the app with a specific flag to capture a snapshot of the shaders during a test run, and then bundle that snapshot with the production app, so the GPU is ready before the user even sees the effect.
That's a very detailed answer. Let's talk about resource management. In a large app, how do you ensure that things like stream subscriptions or animation controllers are cleaned up and don't cause memory leaks?
Reliability in cleanup is all about the lifecycle. The most critical step is overriding the dispose method in a stateful widget. This is where the framework tells you the widget is being permanently removed from the tree. If I've opened a stream subscription or initialized a text editing controller, that's where I must close or cancel them. If you forget to do this, the object stays in memory even though the screen is gone, which is exactly how memory leaks happen. If I'm using a state management library like BLoC or getX, I use their built-in hooks, like the close method in BLoC or onClose in getX. My rule of thumb is always to pair the creation of a resource with a corresponding cleanup call.
Let's talk about project scale. In a large Flutter application, how do you manage dependencies between packages? I'm not just talking about the pubspec, YAML, but the architecture of the project itself.
In a large app, a single pubspec, YAML can become a bottleneck and make the project feel monolithic. To manage this, I prefer splitting the app into smaller, local packages or modules. Instead of one giant lib folder, I'll have separate packages for things like core data, UI components, and feature auth. I then link these using path dependencies in the main pubspec, YAML. This enforces a strict separation of concerns. For example, the UI components package shouldn't know anything about the API implementation in the data package. I then use dependency injection to manage how these packages communicate, ensuring that the dependencies are one-way and not circular, which keeps the project maintainable as it grows.
Just to circle back to something we touched on earlier, could you explain hot reload to someone who might not be familiar with it?
Hot reload is honestly one of Flutter's best features. It allows you to see changes in your code almost instantly, without restarting the entire app. When you save your file, Flutter injects the updated source code into the running Dart virtual machine. The magic is that it preserves the current state. So if you're 5 screens deep into a flow and you change the color of a button, you save, and the button changes color instantly. But you're still on that 5th screen with all your data intact. It makes the iteration loop incredibly fast compared to traditional native development, where you might have to wait for a full recompile.
Last question for me. Imagine you have a very complex UI with a deeply nested child widget, and you need to pass data from the top-level parent down to that child. How do you avoid the prop drilling we discussed earlier?
Prop drilling is a real productivity killer. To avoid it, I recommend a provider pattern or a dedicated state management solution. Essentially, you provide the data at the top of the widget tree. Any child, no matter how deep it is, can then request that data directly from the framework without needing the intermediate widgets to pass it along. If it's a very simple requirement, I might use inherited widget, which is the built-in way Flutter handles this. But for a professional app, I'd use provider RiverPod or BLoC. These tools are optimized for this exact scenario, and handle the rebuilds much more efficiently than a manual inherited widget implementation would.
This has been a great conversation. You clearly have a deep understanding of both the how and the why behind Flutter development. I don't have any more questions for now. We'll be in touch regarding the next steps very soon.
Thank you. I really enjoyed the conversation. I look forward to hearing from you.